Hi, I'm a research assistant professor in the event school and in the PAR group led by Professor Lee Anderson. I work at IPA is related to small-scale producers, inclusive of women, and agricultural transformation in low-income countries. A striking observation from our work is that small-scale producers are increasingly affected by climate shocks, and we found that coping strategies is the most common response, despite decades of supplying technology to farmers. Climate shock is also having a negative impact on household welfare. And we think about this puzzle within a framework that links climate risks to food system changes and to household adaptation decision-making under uncertainty. Our framework highlights gaps in our understanding of SSP's adaptation and challenge to overcome. And to address those challenges, IPA has established a new centers on risk and inclusion in food system that bring together different scientists to research cost-effective strategies for managing food system risk. Thank you for your attention.
Hello, my name is Celina Balderas Guzmán. I am an assistant professor in the Department of Landscape Architecture. Currently, I study adaptation to sea level rise in the US. I use ecological modeling and geospatial analysis to explore how coastal adaptation projects can have regional impacts on other humans and ecosystems. I am looking for collaborations with social scientists or natural scientists in 4 broad areas: climate adaptation to water or flooding issues, the adaptation interdependence between humans and ecosystems, maladaptation, how adaptation can have negative impacts, and designing ecological adaptation responses and policy. I am interested in working domestically or globally, and in urban or rural areas. I look forward to meeting you.
Before I came to the Washington coast, I'd spent a good number of years working with local resilience efforts post-Katrina along the Gulf Coast. Grad school at UW brought me over to Washington. I think some of the most exciting work I've been involved in has been connecting adjacent projects in order to develop more holistic approaches to long-term and short-term changes to shorelines. This all starts with connecting to people on the ground, and then also reaching out to other practitioners at agencies and research institutions. And also through work such as the Northwest Climate Resilience Collaborative's assessment of coastal tribes' adaptation plans and efforts, learning how we can better assist individual tribes as well as regional resilience efforts across the Washington and Oregon coastlines.
I'm Dan Brown, Director of the School of Environmental and Forest Sciences, an interdisciplinary community of natural scientists, social scientists, and engineers. And I'm here to describe our work related to climate mitigation and climate adaptation. Climate mitigation aims to reduce atmospheric carbon, and our work contributes to understanding carbon pools and flows on land, in water, and in derived products, and the linked social and environmental processes that drive them. Climate adaptation aims to identify and plan for climate change impacts. Our work contributes to understanding impacts on plants and wildlife and potential adaptations at the landscape to molecular scales, as well as the often disparate exposures to climate-related risks like drought, fires, and smoke, and how people can respond. Because we work in real places with real people, questions of mitigation and adaptation are often intertwined. For example, our research has explored how management for fire risk can affect carbon storage in ecosystems. All this work benefits from broad collaboration, and I look forward to these conversations.
One of the things that I've been doing lately in terms of climate change related work is focusing on coastal resilience. I've been doing this work for probably 15 years, both in NOAA and now in Washington Sea Grant. And in Sea Grant, over the last 4 years, I've led the national efforts to develop the approach for Sea Grant nationally across all 34 state programs to develop a priority around coastal resilience and developing a funding strategy for that. As a result of my work, we've put resilience as the top priority for Sea Grant in the national funding requests over the last 3 years. And I'm also leading the efforts to advocate with NOAA leadership as well as Congress for those funds. Ultimately, if Sea Grant gets those funds, it will come to the state programs such as Washington Sea Grant and help us address the challenges of climate change and the impacts that we're seeing on the coast and in coastal communities.
Hi, I'm Sharon Doty, and I'd like to tell you about our research on microbial endophytes and how they can be used as a nature-based solution for climate change mitigation and adaptation. Endophytes are members of the plant microbiome. They live inside of plants, and they can provide a bunch of different benefits to the plant host. Trees sequester carbon through photosynthesis, so removing that excess carbon dioxide from the environment. But photosynthesis is limited by nutrient and water availability. Some of these endophytes can provide nutrients through nitrogen fixation and phosphate solubilization. They can increase water use efficiency, and some of them can also increase plant resilience to drought, heat, and salinity. Endophytes can enable the use of marginal lands. So contaminated lands can be treated through phytoremediation using these endophytes, and then that biomass could potentially be used for bioenergy. Also, we can increase the yields of agricultural crops on marginal lands with reduced inputs of water and nutrients. And anytime that we're growing plants, we're sequestering carbon. Harnessing the power of the plant microbiome is a new frontier of research.
I'm Dale Duran from Atmospheric Sciences. Currently, we can't produce useful forecasts of weekly average differences from climatology at subseasonal lead times of 2 to 6 weeks. We can't say if it will be a hotter or drier week than usual. Useful subseasonal forecasts would be of great benefit to society, improving the management of water resources, humanitarian aid, food supply, and energy production. Deep learning weather prediction models are close to competitive with conventional numerical weather prediction. Extending such models to include the Earth system has great potential to improve subseasonal forecasts. Deep learning Earth system models can incorporate satellite observations of conditions at the Earth's surface that are critical for subseasonal forecasts. Their extreme efficiency allows us to produce thousands of forecasts exploring uncertainties in the evolution of the weather, better defining the probable distribution of future conditions. We could use deep learning-based subseasonal forecasts to change the world.
Hello, I'm Bob Freitag, and I'm a senior instructor within the Department of Urban Design and Planning. I'm also the co-director for the Institute for Hazards Mitigation, Planning, and Research. The Institute has been involved in all areas related to hazards and to risk assessments from floods, tornadoes, earthquakes. And most recently, we've been involved in tsunami research and helping with vertical evacuation along the coast. Before coming to the university, I worked for FEMA and I was their federal coordinating officer. And I try to bring a lot of that to the teaching that I do. I teach in 3 courses, floodplain management, hazard mitigation, and community resilience. But what I'm most excited about currently is that we have started a resilience salon, really an area for all of you that are interested in resilience and climate change to meet every 3rd Wednesday of the month for lunch to discuss both resilience and climate.
Hello, my name is Heidi Goff. I'm on the faculty in the School of Environmental and Forest Sciences in the College of the Environment. I do wastewater treatment research. This slide shows how I work with partners to understand how conditions at their site influences their wastewater needs. We use this information for controlled laboratory experiments. We investigate the microbiomes in different reactor designs related to pollutant removal and biomethane production. This helps to optimize clean water and bioenergy recovery. Our community partners are in Western Washington and around the globe. I collaborate with chemists, material scientists, molecular ecologists, and industry partners. I'd be very excited to work with those interested in increasing wastewater research for small, remote, or vulnerable communities.
Hi, my name is Kat Hartwell, and I'm here to talk about the community engagement and climate resilience work that our team is doing in the Duwamish Valley as part of the Seattle Assessment for Preparedness and Emergency Response, or SASPER project. SASPER builds upon the CDC's CASPER methodology, which is a pre and post disaster needs assessment conducted through household surveys. Our project is concentrated in the South Park and Georgetown neighborhoods of South Seattle, both of which are considered environmental justice communities. The SASPER will identify the climate impacts that community members are most concerned about. It will center environmental justice and racial equity in climate adaptation, while strengthening public health emergency preparedness. Several partners, including the Duwamish Valley Community Coalition, the Duwamish Valley Youth Corps, researchers from University of Washington, and the City of Seattle, among others, have collaborated on the creation and implementation of SASPER. Stay tuned for more information on our findings, and thank you.
I'm David Hendry, Associate Professor in the Information School and Co-Director of the Value Sensitive Design Lab. Addressing the climate predicament requires sustained social and technical transformations across generations. This is partly an information problem because the information systems we build today create the conditions for acting in the world in the future. At the Information School, faculty and students investigate the fundamentals of data, information, and knowledge. Collectively, we are interested in many topics related to the climate predicament. Working within value-sensitive design, my research is currently focused on community-driven resilience and visioning and policy design, acting now with an eye toward future generations and creating new methods in value-sensitive design for resilience thinking and policy innovation.
My name is Scott Kalifatis, and I recently started at the UW as the Deputy University Director of the Northwest Climate Adaptation Science Center. I'm a social scientist, and in the past, I've studied relationships between climate scientists and a variety of different partners as a part of NOAA's RISA program. As a postdoc, I focus specifically on assessing the experience of Native American tribes in these collaborations. I spent the last 4 years as an assistant professor, but I wanted to more thoroughly connect science and practice. At the Northwest CASC, I'll be working on our annual deep dive that facilitates engagements between researchers and practitioners around emerging climate risk in the region. And I'll also be running our fellows program that supports graduate students developing decision-relevant science. Climate change provides opportunities for science and practice to enhance one another. I'm interested in how social science can contribute to collaborative efforts that are, at their core, about people, how we interact with our environments, how we make decisions in an uncertain world, and how we learn to understand and work with one another more effectively over time. Thank you for your time.
Hello, on behalf of our project team, we are Dan Abramson, Lynn Manzo, and Julie Cree from the College of the Built Environments. Our project with the Shorewater Bay Indian Tribe on the Pacific Coast explores strategies for community resilience in the face of climate change, where slowly rising seas, eroding shorelines, and changing weather patterns impact the lowlands. Hazards from earthquakes and tsunamis are an imminent threat to the tribe's way of life. Expanding on the tribe's interpretation of resilience as revitalization of traditional foods, culture, and wellness, we adopt a 7 generations approach to planning and designing, leveraging knowledge and wisdom from past to inform strategies for future upland expansion, and anticipating future changes in the environment and the needs and creativity of future generations, building a social, economic, and ecological ecosystem with new uses for local materials and living species, which are revealed through co-creative engagement by the team and community members together to create a place where community members will not only survive, but also thrive.
I'm Meade Crosby, the University Director of the Northwest Climate Adaptation Science Center, or Northwest CASC. The Northwest CASC is a consortium of 6 universities across the Northwest who work closely with our partners at the U.S. Geological Survey to deliver actionable science to help fish, wildlife, water, land, and people adapt to a changing climate. The consortium provides this science in 2 primary ways. First, through the Northwest CASC Research Fellowship Program, which provides funding and training to graduate students and postdocs to support their co-production of actionable science with Northwest resource managers. We also conduct an annual deep dive, a facilitated process convening scientists and managers to synthesize the state of the knowledge and practice around an emerging climate risk so that we can identify key gaps in science and capacity to inform future science investments. To learn more about the Northwest Cask and our programs, including skills building resources for actionable science, please visit our website. Thank you.
Hi, everyone. My name is Guillaume Moget. I'm a research scientist at the Climate Impacts Group, a member organization of Earth Lab in the College of the Environment. My pronouns are he, him, and his. My research focuses on supporting climate adaptation in the Pacific Northwest, focusing primarily on flooding and floodplain management, but also on water supply. My work is a combination of technical and decision support. I work on climate projections and streamflow modeling, generally in partnership with the community, working to help them understand their risks, strategies, priorities, and how those might be different with climate change. What I've learned from this work is that the action on climate change is dependent on a whole slew of other factors, social, economic, political, institutional, and others. And I'm interested in working with experts. I know there's a lot of expertise in this area at UW. Who have an interest in floodplain management, water management, or a related topic. Thank you.
My work seeks to inform planning for climate change and specifically sea level rise by trying to better understand what sea level rise means for Washington shorelines like the one behind me near where I live in Port Angeles. The shorelines of Washington state are of course critically important for ecological, cultural, and economic reasons. And understanding the impacts of sea level rise is much more complicated than just mapping or modeling where water will go in the future. We also have to try to understand how our communities use and value and think about the shoreline and how those uses and values interact with the rising water. The map you're looking at is a product of a recent project I co-led, and it's an attempt to quantify this concept of sea level rise vulnerability for properties along the shoreline of Puget Sound. Research like this is informed by Washington Sea Grant's ongoing engagement with Washington's coastal communities and will prove useful to the daily decisions about how to live with and along Washington shorelines.
My name is Margaret Redsteer, and I'm an assistant professor in the School of Interdisciplinary Arts and Sciences at the University of Washington, Bothell. And I work on climate change adaptation, planning, and assisting reservation communities in the Western U.S. because climate change is underway, even if we mitigate greenhouse gas emissions tomorrow. The areas most sensitive to climate change are also the homes of Indigenous people where I work. These impacts will continue, and we have to adapt. And in some places, people have already been adapting and relocating. As a physical scientist, I also focus on the interface between landscapes and climate, including sand dunes that are sensitive indicators of local climatic conditions.
Hi everybody, my name is Samir Shah, pronouns are he, him, and I'm a new assistant professor of climate adaptation here in the School of Environmental and Forest Sciences. I'm broadly trained as an environmental social scientist who studies the human dimensions of climate change vulnerability. My research falls into three main buckets. The first is understanding the socioeconomic and political processes that condition the uneven impacts of climate change and variability within our communities, including on food, energy, and water systems. The second is analyzing the equity, justice, and sustainability dimensions of climate adaptation and disaster recovery. A lot of this work right now is happening in Puerto Rico and Western India. And third is learning from communities about the solutions necessary for climate justice. My collaborations on campus so far are largely within landscape architecture and CEFs. I'm very much interested in interdisciplinary collaborations, particularly in human geography and physical geography. Thank you very much.